All right, good morning, everybody. So today I am going to go over something that you probably already know a little bit about and used a good bit last year, but it's probably been a while since you've used it, so you don't have the formula memorized. And also, it was probably not explained to you or shown to you where the quadratic formula came from. So we are talking about the quadratic formula, and the how the quadratic formula was derived is they actually took the standard form of an equation, which is ax squared plus bx plus c equals 0. They took this right here, this ax squared plus bx plus c equals 0, and they completed the square on this equation to get the quadratic formula. So you didn't know that because you weren't taught how to complete the square last year unless you were in honors algebra 2 or pre-calc. But that equation is derived by simply completing the square on the standard form of an equation. So they did it with the letters instead of the numbers. So it's kind of a cool process. So I like to take the time to explain that to my classes just because they have a way to maybe now understand what's going on. So let's try it. So here's the proof of a quadratic equation. And so you can see that we have this ax squared plus bx plus c equals 0. And the first thing we're going to do is we are going to move the c to the other side. Now, this is similar to how I showed you guys how to do it, but not quite the same in that the I normally just group the two x terms together rather than moving the constant over to the other side. But it's the same idea. Now, the next thing that they're going to do is they're going to divide this equation through by a, because as you know, if there's a lead coefficient, a, and it's not 1, you can't complete the square. So what they do here is they divide this term by a, which eliminates the a. They divide this term by a, which makes it b over a times x. And then they divide this by a, which gives us c over a. And then that term is negative, obviously. The next thing to do is to complete the square. So off to the side, if you were to take b over a and you divided it by 2, you would end up with b over 2a. And then when you squared that, you would get b squared over 4a squared. And so they added the new term here after this, b squared over 4a squared on this side. And then they added the b squared over 4a squared on this side. So they had this equation and they added the same term to both sides. Okay, and that is that b over 2, the quantity squared. The next step then is to factor this into x plus b over 2a, the quantity squared, equals negative c over a plus b squared over 4a squared. So you can see the right-hand side didn't change. The left-hand side factored into the b over 2a, which is what we had before we squared it if you were had that scratch work off to the side. The next step would be to take the square root, because remember, don't lose sight of what we're doing. We're completing the square on this so we can solve for x. So we would square root both sides. And in doing so, well, I lied. I apologize. They're not going to square root both sides first. They're going to get these two together into one fraction. And so in order to do that, you need to have the same denominator. So you can see this fraction has a 4a squared, whereas this fraction just has an a. So the top and the bottom of this fraction need to be multiplied by 4a first, which is what we get right here. So you can see the top was multiplied by 4a, the bottom was multiplied by 4a. And now what we have is a denominator that are same. They're both 4a squared. So we can then combine them into one fraction. So you have negative 4ac plus b squared over 4a squared. Now they're going to start solving for x here, which is to get rid of the square by square rooting. Okay. They did flip around the b squared and the minus 4ac to this. And then the last step would be to subtract b over 2a to both sides. Notice, too, that they did take the square root of the 4 and the a squared, which gave us 2a on the bottom. And then they're going to subtract the b over 2a. And so this is the quadratic formula. So you can say they have the same denominator, so you combine them, and you get negative b plus or minus the square root of b squared minus 4ac over 2a. And so what I want you guys to understand from that, and you don't have to worry about it, you will not be asked to reproduce that proof or anything like that. And if we were in person, I would actually take more time and explain step by step by step, very, very detailed, to show you how to do this. And I'm never going to ask you to do this on your own, but I want you guys to see how that formula was derived. And it was derived by taking the standard form of a quadratic and completing the square. And so it makes it convenient that now to solve these quadratic equations, you don't have to complete the square every time. An alternative to completing the square is using the quadratic formula. And last year, that's what you would have used, which is the quadratic formula. And so, couple things about the quadratic formula is it always works no matter what, just like completing the square. So it will give you the imaginary solutions. It will solve quadratic equations that are not factorable by any other means, but it will still give you an answer. So how would you solve this using the quadratic formula? Well, the first thing that you would want to do is you would want to get this in standard form, okay, which would be x squared plus 3x minus 9 equals 0. And then what you would need to do is you need to determine what A, B, and C are so you know what numbers to plug into the formula. So in this case, A would be 1, B would be 3, and C would be negative 9. And so what we would do is you would plug A1 in for A, you would plug 3 in for B, and you would plug negative 9 in for C. Now, there's something that I need to mention. It's very important. In your book calls this form right here general form. All right. It is, I have no idea why they do this. They are the only book I've ever seen in all of my experience teaching math and learning math through school that calls this general form. So please understand that when you see the book and it says general form, they mean standard form, which is all the stuff on one side, get it equal to 0. So as you can see in this pink, I didn't change it in the slide on purpose because I wanted to make sure you're aware that in the directions, if it says write the equation in general form, they are talking about standard form. So you can see once I substitute A is 1, B is 3, and C is negative 9 in, you can proceed to simplify this. My advice to you would be to not type this into your calculator for a couple of reasons. One, I don't want decimal answers. And two, it is actually kind of tricky to type this all in and get the correct solution, making sure you use parentheses and getting order of operations correct. It's really just easier to do a little simplification. It's pretty easy. 3 squared is 9. And you can see you have 4 times 1, which is 4. And then 4 times 9 is 36. So you end up with 9 minus 36. I'm sorry, 9 plus 36 under the square root, and 9 plus 36 ends up being 45. And so this simplifies. 45 will simplify a bit more. 9 is in 45. 45 is 9 times 5. So the 9 will come out as a 3 right on the outside, and the 5's left behind. And then this ends up being your final answer. I do not want decimal approximations. I want simplified radical answers like this. So negative 3 plus or minus 3 root 5 over 2 is your final solution. And it does give you 2. If you're confused, remember the plus means you would add it and then you would subtract it, and there would be 2 different answers. So this one, I'm not sure why all these steps popped up at the same time. I didn't mean for that to happen, but let's talk about it. So you have 2x squared minus 5x plus 8 equals 0. This is already in standard form. You can say it says write in general form. Again, standard form. The book says general. It's called standard. That's what we call it. That's what I will continue to refer to it as, but you need to know what it means when the book says general form. You plug in all your numbers, right? So negative of negative b. So negative of negative 5 plus or minus negative 5 squared minus 4 times a times c. And then you have times 2a, right? So standard form, identify A, B, and C first, and then plug them into the formula. My advice also would be to write the formula out before you use it. That way you commit it to memory. It's very simple if you repetitively write things down before you use them. It makes it really easy. Now you can see here this double negative becomes a positive 5. Negative 5 squared becomes 25. And then you have negative 4 times 2, which is 8. 8 times 8 is 64. Now what we end up with now is 25 minus 64, which is negative 39. So we're taking the square root of a negative number. And anytime you take a square root of a negative number, that is going to give you an imaginary solution. So you can see 5 plus or minus the square root of negative 39. 39 does not have any perfect squares in it, so we leave the 39 alone, but the negative comes out and becomes an I, and then this is your final answer. Okay, so again, there's a quadratic formula. You guys should know how to use this from last year. Okay, so that's what I got for you. Hopefully that made sense. Have a great day.